We are delighted to welcome another person who is familiar to many of you, and he brings vast experience of not just refrigeration solutions, but also the wider UK cold chain. He embodies the Star refrigeration philosophy that is about not only providing brilliant solutions and customer service, but also takes the responsibility as a leader for change very seriously. He's here to tell us about the technology that will shape the future cold chain. We've had an idea of some of that in the two previous speeches. Hopefully we'll have a lot more detail from our guest speakers. So please give a very warm welcome to the Sales and Marketing Director of Star Refrigeration, Dr. Rob Lamb.
So yes, thanks to the two previous speakers, and thanks for the kind introduction as well. So what does the future have in store for us in the cold chain operators, and what does our role as suppliers and engineers look like in the years to come? And I want to touch on that this morning. A brief insight, as a business in Star Refrigeration, where I've worked for the last nearly 25 years, we've been leading innovation. Some photographs there over the last 50 plus years of our business, starting in the top left, all the way through. We've been developing innovative solutions that have been helping customers drive down things like energy costs across the food chain, cold chain, things like food production, also leisure and ice, building services, but always looking at that innovation and how we can drive that forward. So I'm going to give some insights into that this morning, but also talk about a little bit broader as well over the next 20 minutes. So why do we need that? What's driving all this innovation? Well, we've seen just this summer the effects of global warming, the rising temperatures, 40-degree temperatures for the first time in the country. It's already been mentioned this morning, and we're hoping to hear news later on this morning around energy and the costs and increasing costs of energy. And just as we see that, 5 years ago we were talking about energy costs, and we were doing energy reduction calculations on 8 or 9 pence per kilowatt hour. Wow, they were some time ago, weren't they? Things have changed somewhat. And with that increasing in temperature as well, globally, we're going to see scarcity of resources. We're going to see growth of populations, relocation of populations, and we're going to see that filter down to here. We're going to see potentially more drought situations. We've already seen scarcity of raw materials through things like COVID. So taking all of those things into consideration, logistics and the cold chain is having to change and to adapt to that. With things like changing of eating habits, move towards more plant-based eating as well. We're going to touch a little bit on maybe how that could affect things in the future. And the logistics models that we're working on as well. That sort of final mile logistics, and what does that mean in the future? What is the technology? What are the models that we're going to be working through? So the question I was posed in terms of this talk this morning is, what can the cold store operators expect from us engineers? Graph paper, lots of calculations and lines and drawings and dimensions and things like that. But in all seriousness, focusing on things like energy, looking at sustainability, what does the future actually hold? And I thought, well, a good place to start is making sure that we're building our future on solid ground. I remember the Bible story of the two guys, one built on sand, one built on stone. The guy that built his place on the sand quickly got washed away when the storms and the troubles came. Now we're in a very stormy time at the moment, so this morning I really want to talk to you about how we can make sure we build our foundation on solid ground, solid stone here. And all that's really focusing, a lot of it we'll be focusing this morning around sustainability. Why have we got to look at that? Well, we already have emission targets. They're going to become much, much more stringent as we move forward, as we're trying to meet a net zero target into the future. We know about increasing energy costs, and we're going to see more benchmarking. We're going to see more requirements to meet certain targets in the future, particularly around sustainability and energy. And we need to be ready for that. We need to be prepared for that. We need to be looking to the future and saying, what does that look like? Otherwise, it could be very expensive for us to try and take action later on down the line. And in terms of things like how we're going to achieve that, well, particularly looking at things, and I'll talk about construction this morning, things like materials, even to points of where we locate and orientate our buildings, looking at how we select the equipment that go into our facilities, how we run the facilities, how we source our energy. And then when we're actually operating a facility, it's great to have something that is operating efficiently at day one, but how do we maintain and how do we analyze that and look at it into the future and say, is it doing what it should be doing? And then a little bit on recycling, about materials, but also energy. How can we recycle all this energy that we chuck away as an industry? Gigawatts of energy we throw into the atmosphere every year. We don't do anything with it. So starting off, in terms of energy performance, looking at energy in our industry, took this graph from one of the infographics that has been published by the Cold Chain, and it's been positive news over the last 9 years in terms of the work that's been done in the Cold Chain. We should reflect on that and celebrate that. We've each couple of years set targets have been set, and the industry has worked together to actually not only meet but beat those targets. But I don't know about you, but when I was at school, I always ended up with a report with something on it that said, could do better in certain areas. And really, for me, I think this is one of the key messages from this morning, is that we can do better. And I want to give you the confidence that that is actually possible. The graph here shows sort of data in terms of European average kilowatt hours consumed per meter cubed of cold storage. The blue line at the top there is for chill, then you've got green in frozen and grey in mixed facility. Now, if you look at those, that's data taken from around 2013, 2014 of hundreds of stores across Europe. And what you'll notice is that actually those stores are consuming far more energy than the best practice that we developed in this country back in 1994. So we've got stock that isn't operating as efficiently as it could be, and not as efficient in line with practices nearly 30 years ago. But work that's been done in terms of new facilities also gives us real great hope that we can reduce energy consumption by as much as 85% through using innovative technology, through the way that we construct buildings. We've got a huge opportunity to reduce the energy within our existing portfolio, and as we move forward building new facilities. And that will help us, and that's why I believe we can do better. You're looking at things of how we construct, well, we have a first part, in terms of the materials that we use. There's some great work been done in terms of insulation materials, for example, around sustainability, reusing that, and which is going to be important in the future. But also selecting the right sort of type of material, the right thicknesses of material. They all help to reduce the amount of energy that you're using in a facility and driving that down. And also ongoing maintenance. I was asking for some sort of indications of how bad this could actually be, and a couple of photographs in the bottom corner there of roofs of cold boxes which are really poorly maintained. We can do much better than that, and that raises some health and safety issues, which I think in the future, in terms of where engineers are going to be knocking on doors, are saying, how do we look at working in our roof areas, in our roof voids? How do we make sure that we're maintaining and ensuring that they're safe to work in? Because that will be important in the future. We've got a lot of old stock that's in pretty poor condition. How do we learn from that? How do we improve it? And how do we build better? In terms of construction, we're really going to have to start looking about new design conditions. The higher ambience that we've been seeing this summer aren't going to go away. Traditionally, we've designed in the UK for a 35 ambient. I've got more and more people saying to me, should we be looking at 40? Should we be going higher than that? Should we be looking at 45? We're going to have to really look at that. Also, regional variations. Traditionally in Scotland, we've typically designed for less than 30 degrees, but now seeing much higher temperatures there too. But also, when we are designing, what are the things that we can be doing in our local area? And I'm going to touch on how we can use some of our heat waste on that shortly. But also focusing on orientation, things like that of the building. How can we maximize the benefit of things like solar? Solar is being installed, it's going to be important for the future, but how do we orientate our building to make sure that we're getting the most of that? But at the same time, looking at things like refrigeration. Too often, the refrigeration plant gets placed wherever's left when planning a building. And if it's sat on the south side of the building, as we saw in the recent hot weathers, it is working in very, very high temperatures. We were measuring air around refrigeration systems approaching 50 degrees this summer. No refrigeration plant is designed to work with air rejecting heat into a 50-degree ambient. Touching a little bit in terms of where legislation is going, we've been working within our industry with the F-gas regulation since 2015 in the chart that we see here. We've been phasing down the CO2 equivalent of refrigerant that we've been supplying within the industry as part of our commitments to climate change. And what that sees is at this moment in time, we've seen a 55% cut versus benchmark from 2015 in CO2 equivalent being put into the marketplace, with further steps due in 2024 to a cut of 69 and then 76 by 2027. And the plan with F-gas regulation was always based around a 2030 point where we were looking at a 79% reduction. And we're performing well, we're working with that. We've seen hikes in refrigerant, but ultimately we've not really been looking where the future is going to head as we head towards 2050. What it has meant is we've seen removal of things like 404A from systems, replacement of that, and even more modern refrigerants that have been replaced are now sitting well above those sort of timeline phase-down targets. We've also seen within Europe new draft legislation that was issued on this to revise the F-gas regulation to actually accelerate that phase-down. It will actually bring forward the 2027 cut to 2024, less than 2 years away, less than 18 months away now. And what it is actually looking to do is to get us down to a 95% reduction of CO2 equivalent refrigerants that are supplied to the market by 2030. That's a big step, because the majority, if not all, of the refrigerants that are synthetically made that we're using at this moment in time, so the HFCs, are way, way above those sort of limits. And we're now looking at potentially what it should look like in terms of refrigerant supply for a 2050 target within this. So this is draft at the moment. It looks like it's going to be moving through in it, and some of these numbers may change, but what we've tended to do is adopt that anyway in the UK, even though this is an EU draft at the moment. Why is that important? Well, from our own cold chain data that we've got, there's still 38% of our stock that is operating on HFC refrigerants. And what we're likely to see is that in the past, where we've dropped in refrigerants, so we've done changes, those drop-in fluids aren't really available at this moment in time in terms of synthetic refrigerants. So even if we do a drop-in, it's going to be subject to this phase out. So we're going to see a growth in what we would typically term as natural refrigerants, I believe. So the ammonia percentage there of 56% is likely to become a bigger share of that pie. And refrigerants like carbon dioxide are also likely to increase, and we're seeing that already. In terms of our operation, I'm sure we'll hear more about automation, and that's obviously been driven by labour costs, better productivity. Susan already talked about the need to improve that as well, and that's going to continue into the future. We're definitely going to see that. That's going to drive potentially more energy on our sites, which I'll touch on later as well. But also we're going to need new skills. We're now going to need software engineers, we're going to need automated engineers. Are these people available? Are we moving at the right sort of speed for that? And that's going to be a challenge. But we also need to look at how we operate our stores and reducing heat gain. It's always a point that, as refrigeration people, we're always striving to do. Our ideal is to have no doors to any facility, because obviously there's no heat gain at that point. It's at a total opposite to what we want in terms of logistics, because we need to move boxes around. But better operation of our stores, better design of doors and control of doors, things like airlocks and dehumidification we're seeing more and more of, and that's going to grow, I think, as we try and reduce heat gains into buildings. But staff awareness is a very simple thing. We see turnover of staff in facilities which is quite high. In 5 years, after doing a lot of training about staff awareness on heat gains into buildings, those staff aren't there. That good practice has been lost. Energy bills start to go up, and that's going to really affect businesses, particularly with high energy costs at the moment. In terms of some technology, I believe we'll see more in terms of flexible cooling solutions that are simple to install. More packaged solutions we're seeing now coming onto the market. One of the big advantages there is relocatable. You can, depending on how your business changes, you can pick it up, you can move it somewhere else. You can operate it at different temperature levels, and businesses are looking for that flexibility. It becomes then an asset to your business that you can move around rather than a sunken cost. Quite a lot of work just recently looking in things like blast freezing, and quite a bit of technology coming in there. We've typically blast froze at -40, quite inefficient, using maybe rental plant, big energy consumer. But actually there's technology out there that we can improve efficiency and operation by doing our blast freezing actually inside our cold stores at a much higher temperature, which will drive down energy costs. And it's allowing for variability of product, and it means better operational efficiency, because you're not moving products in and out of blast freezers all the time, and all the labour that's associated with that. Taking that one step further, just putting something out there in terms of vertical farming, a lot of work around that taking place probably outside of our immediate industry at the moment as we see it within the cold chain here, but with a growing population and that move towards more plant-based products, shortage of arable land to actually grow on, you've got this big benefit if you sort of build in a vertical farm, in that you can have multiple tiers of product all growing within the same square meter area of floor. And we have great expertise in this area. We've been keeping things cold for many years. So is this something that we can maybe turn our hands to and not just store but grow in the future? one of the points that was mentioned, I think Susan mentioned it earlier, was about loss of product. You know, if we're growing and storing, we cut out one of those major areas where we lose a lot of product, a lot of agricultural product, which is post-harvest cooling. A lot of our product that is dug out of the ground doesn't actually get anywhere near the shelves. It's lost long before that because we're not cooling product early enough. In terms of renewables, I'm sure, again, we'll hear more about this as we go throughout the day in the energy zone and elsewhere. But, you know, we're going to move to carbon-free production of power. And, you know, we're also going to see increased energy demand. All this automation all needs power. What are we going to do with our vehicles if we move to things like electric vehicles, even to sort of hydrogen vehicles? How are we going to do that? That's going to potentially increase demand on site. So we're going to need more and more of that energy and really moving towards renewable. Some of that we're looking to buy in, but again, solar, wind, can we do more of that on site? Even hydrogen production, this development work of potentially providing hydrogen production on a small level, so you could maybe have that on site locally as well. Ammonia is actually one of the feed sources for that. So that's something that potentially could be coming around the corner. And then using big data, all the data that we're collecting at this moment in time, historically we've tended to look too far in the rearview mirror in terms of how to run our businesses, when actually we can be looking out way ahead into the future, using data that we can collect on site that's readily available to actually say, how is our operation working? How can we model that in real time and actually identify it and make changes quickly? That's available now. You can actually develop models which look at the actual performance of systems on site, whether that can, in this case, it's a refrigeration shown on the drawings, but it can be anything else as well. And how is it performing compared to how it should do? Can you identify where there are shortfalls? Can you predict into the future, if you continue to operate like this, what effects it's going to have on your business? Because that's going to be important. The more that we do benchmarking, whether that's benchmarking on cubic meter or per pallet, you're going to be looking at benchmarking and targets that you have to meet in terms of those into the future. There's already been white papers published on this by government in terms of looking at drafts of how this could potentially happen. And we've done some good work in integration in terms of things like load shedding and this demand-based response systems that are out there, force running and based upon demand and energy prices. But there's more that we can do that, feeding in things like ambient temperature, weather data, throughput predictions for the site, which will all help to decide whether we can keep our refrigeration systems running, or depending on what we see happening in the next few hours, do we switch it off because it's high ambient and therefore we can save some money in doing that. That's all possible. It's feeding the information in, working closely together in collaboration of how we can fit that together. And then in terms of, I mentioned about recycling of our waste. We chuck away gigawatts of energy within our industry every year as we try to cool things down. How can we actually capture that heat? Heat is going to be one of the big challenges that we've got in our country here in the future in terms of decarbonisation, in terms of climate change. We've chucked lots of it away. How can we use that? We can actually capture that heat. Could we be using that to supply heat to local business parks, distribution parks? We're seeing more interest in this. We're seeing parks being proposed where we're linking cooling and heating users. Could we feed all that waste heat into district heating networks? Can we transform what we currently class as a waste that we're chucking out into the atmosphere as a revenue stream? We should really be exploring that. What does that look like? Do I have a fridge plant that can do that? Am I designing for the future? Do I take pipes to the boundary of my facility so that when the district network runs past, I can put my heat into it and look at that as a stream of revenue? So in summary, we really do need to be planning for that sustainable future. We need to be building on that solid ground. We'll be focusing on the longevity of our systems, of our sites, our facilities, real focus on how we can get the efficiency, not just at the point of installation and getting the site operational, but throughout its time, and recycling some of that waste heat we talked about as well. But a real point I think that will be a challenge for us all, and we need to work together on, is that training aspect of it. The skills that we're going to need in this industry are going to change as we move into the future, and making sure that that's invested in. So plenty to consider in all of that, and be happy to chat through that through the discussion sections. But I just wanted to leave you with one thought, that change, the secret of change, according to Socrates, was that you focus all your energy not on fighting the old, but on building the new. So we all need to start to focus our energies in that.